Hello and welcome to another video tutorial. In this video I'm going to show you what the sine rule is and how to use it to answer exam questions. The sine rule is provided to you on the formula sheet on the second page of the International GCSE Maths paper. So let's see what the sine rule is. In triangle ABC, we label each side with the lowercase of the same letter of the angle opposite to that side. So we label the side opposite angle A with lowercase a, the side opposite angle B with lowercase b, and the side opposite angle C with lowercase c. Then the sine rule formula tells us that if we write the side A over sine of its opposite angle A, then that would be equal to side B over sine of its opposite angle B, and then that's equal to side C over sine of its opposite angle C. In fact, the formula tells us that if we have two of the sides and their opposite angles, then there's enough information for us to use the sine rule. So the hint to remember is that we need two sides and their opposite angles to be able to use the sine rule. An exam question. Work out the value of x, give your answer to one decimal place. The question that we always ask ourselves is, can we use the sine rule? Here we have two sides, and for each side we have its opposite angle. Therefore, the answer is yes, we can use the sine rule. To write the sine rule, we always write the side on the top of the fraction, as you can see in the formula. So we write the side x over sine of its opposite angle 38, and that is equal to the side 13 over the sine of its opposite angle 100 degrees. Since we are working out x, we cover it, and then we use cross multiplication. We cross multiply sine of 38 by 13, and then divide by sine of 100. So let's write it down. X is equal to sine of 38 times 13 divided by sine of 100. We type this in our calculator and we get 8.1, which is to one decimal place as the question wants, and it's centimeters.
Another exam question. Work at the value of x, give your answer to three significant figures. Again, the question that we ask ourselves is, can we use the sine rule? We have two sides, and for each side we have its opposite angle. Therefore, the answer is yes, we can use the sine rule. We write the sine rule by looking at the formula. The formula tells us that you write the side on the numerator. So we write the side 5.4, which is opposite the angle x, on top of the fraction. And we write it over sine of its opposite angle, which is x, equals the side 6.7 over sine of its opposite angle, which is 95 degrees. We are trying to find the size of angle x, but angle x is inside sine, so we have to cover all of sine of x. And we use cross multiplication by cross multiplying 5.4 and sine of 95, and then divide by 6.7. So we write sine of x equals 5.4 times sine of 95 divided by 6.7. We plug this in our calculator and we get the following answer. 0.8029. Remember that this value is for sine of x. In order to find x, we have to use something that we call sine inverse or sine minus 1. So we write x equals sine minus 1, and we put this number inside it, inside brackets, 0.8029. We call this the inverse of sine, and in order to type it into our calculator, we should press shift, then sine, which gives us sine inverse or sine minus 1, and inside brackets we type in 0.8029, brackets closed, then press equal. That gives you the angle. The question says give your answer to 3 significant figures. So we write the angle to 3 significant figures, which is 53.4. 53.4 degrees, correct to 3 significant figures.
In this question, we have 2 triangles that are attached together along one of the sides, and the question wants us to work out the value of x and give our answer to 1 decimal place. We separate the triangles so that we can analyze them easier. The length x is in the triangle that is on the left hand side, and we have 2 angles in that triangle. Now the question that we ask ourselves is, can we use the sine rule because we have 2 of the angles? Well, in order to use the sine rule, we need 2 angles and their opposite sides. The length x is one of the sides, but it's opposite this angle, that we can work it out easier. So because the angles inside a triangle add up to 180 degrees, we add 40 and 65 together, which gives us 105. Then we take it away from 180. That gives us 75 degrees. Therefore, this angle here is 75 degrees. So we have the side x and its opposite angle. If we have another angle and its opposite side, then we can use the sine rule and work out the length x. What we notice here is that the side that is opposite angle 40 degrees is common between the 2 triangles, and the triangle on the right hand side is a right angle triangle in which we can use Pythagoras. So we can use Pythagoras in the right hand side triangle in order to find this side. Let's call it y, and then since that side is in common, then we can again go back to the triangle in the left hand side and work out the value of x. So let's use Pythagoras in the triangle on the right hand side. Using Pythagoras in the triangle on the right hand side, we have y squared plus 5 squared equals 13 squared. So it gives us y squared plus 25 equals 169. We subtract 25 from both sides, so we get y squared equals 144. Then to find y, we square root, so we get y equals square root of 144, and the answer is 12. So that means that the length of the side which is labeled as y is 12 centimeters. So we can write 12 here. So since the side is in common, then we can write 12 here as well. Now going back to the triangle on the left hand side, we have 2 sides which are x and 12, and their opposite angles, which are 75 degrees and 40 degrees. Therefore, we can use the sine rule in the triangle that is on the left-hand side. So we write in this triangle here, we write x over sine of its opposite angle 75 equals 12 over sine of its opposite angle 40 degrees. We are working out x, we cover it, and then we use cross multiplication like we did before. And we get x equals sine of 75 times 12 over sine of 40. We put this in our calculator and we get the answer 18.0 to 1 decimal place as the question wants. In this question, as we will see, we have a combination of the sine rule and the cosine rule together. Click on the link above to watch my video on the cosine rule. The question says, ABCD is a quadrilateral. The diagram is not drawn accurately. Work at the length of DC and give your answer correct to 3 significant figures. Once again, we draw the triangles separately so that we can analyze them easier. The length DC, which we label by the letter X, is in the triangle BDC on the right hand side. In that triangle we have two angles, 40 degrees and 80 degrees. So we might be thinking of using the sine rule to find X. But remember that to use the sine rule we needed two angles and their opposite sides. For the 40 degrees angle we have its opposite side, which is X. But for the 80 degrees angle, the opposite side is not given to us, so let's label it by the letter Y. But we notice that the length BD, which we have labeled by the letter Y, is in common between the two triangles. So we can write Y for BD in the triangle on the left-hand side as well. Now we can see that we can move to the triangle ABD on the left-hand side and use the information in that triangle to work at the length Y and then move back to the triangle BDC on the right hand side and use the sine rule to work at the length X. So let's use the information in the triangle ABD on the left hand side. In that triangle we are given one side, two sides, and three sides and one angle. So these information meet the condition for using the cosine rule. Remember that the condition for using the cosine rule was three sides and one angle. So here we have three sides and one angle, therefore we can use the cosine rule, and we also remember that the cosine rule always starts with the side opposite the given angle. The angle is 78 degrees, so we start the formula with the side Y, which is opposite it. So we write y squared equals 8.2 squared plus 5.6 squared minus 2 times 8.2 times 5.6 and times cos of the angle 78 degrees. So we write y squared equals, and we type these numbers into our calculator. We press equal and we'll get 75.18539. In order to find y, we have to take square root of both sides. So we take square root of 75.18539. The answer that we get is 8.67. So this is the length y. So if we, instead of y in the triangle BDC, if we write 8.67 for y, then we notice that we have two angles, 40 degrees and 80 degrees, and for each angle we have its opposite side. Therefore, we can use the sine rule, and therefore we can find the length x. So let's do that. So we write the sine rule by writing x over the sine of its opposite angle, 40 degrees, equals the side 8.67 over the sine of its opposite angle, which is 80 degrees. Since we are working out x, we cover it, and then we use the cross multiplication in the usual way. So we write x equals sine of 40 times 8.67 divided by sine of 80. And the answer that we get is x equals 5.66 centimeters, correct to 3 significant figures as the question wanted.